Okay guys, here is our chapter 3 review. So I'm going to start off with number 1. It just says solve. So I'm trying to find what x equals. So the first thing I do is I look and I see, can I factor? Are there factors, if I multiply a times c, are there factors that multiply to give me 10 but add to give me 3? And that doesn't happen. Since it's a quadratic, I'm just going to use the quadratic formula. So a equals 2, b equals 3, and c equals 5. So I'm going to say x equals -3 plus or minus the square root of 3 squared minus 4 times a, which is 2, times c, which is 5. And I'm going to divide all of that by 2 times 2. So now we just go through and we simplify. We have -3 plus or minus 3 squared is 9. 4 times 2 is 8, times 5 would be -40. Divided by 4. Simplify that a little more. We have -3 plus or minus 9 minus 40 is -31 divided by 4. I see this negative underneath. That means I'm going to have an imaginary answer, an I. So we're going to simplify a little bit more. I have -3 plus or minus. I'm going to bring that I outside, and I cannot reduce 31 over 4. So there's my two answers, -3 plus I root 31 over 4 and -3 minus I root 31 over 4. Same thing here. First, you try and factor. So 3 times 5, are there factors of 15? That'll multiply to give me 15, but add to give me a -2. So we'll simplify a little more. I have 2 plus or minus. I see there's a negative underneath there, so it's a -1. And then 56, I can break that up into 14 times 4, because 4 is a perfect square, over 6. So I take this -1 out, and it becomes an I. The square root of 4 is 2. So I am left with 2 plus or minus 2I root 14 over 6. And then we always have to simplify. So I'm going to separate this and write this as 2 over 6 plus or minus 2I root 14 over 6. And see if I can simplify. Well, 2 goes into 2 one time, 2 goes into 6 3 times, 2 goes into 2 one time, 2 goes into 6 3 times. So I can rewrite this as x equals 1 plus or minus I root 14 over 3. Again, two imaginary answers. All right, guys, these next ones are kind of long, and it does take a minute for us to get through them, but it's important that we take our time and pay attention to what we're doing. Okay, if we're given a 0 of x equals -3i, we're also given the 0 of x equals +3i. You always have to account for the complex conjugate. So I'm going to first multiply these two together, make them into binomials, so x plus 3i, and then x minus 3i. And I can still use our little shortcut. I have x is the first term, so that's x squared. And then I have minus, because they're the difference of, and then 3i is the second term, and that's squared. So this 2 goes to both of these. So I'm left with x squared minus 9i squared. And when I see I squared, I cross it off and make it a plus. So I'm left with x squared plus 9. So now we take this and we divide it into that. We use long division. So I'm going to say x squared. I'm going to use 0x as a placeholder so I don't make any silly mistakes. And then I put 2x to the 4th plus x to the 3rd plus 15x squared plus 9x minus 27 all underneath. Now we're going to do our long division. And you got to just be careful. X squared into 2x to the 4th. Well, that would be 2x squared. So get your division ready. Your multiplication ready before you subtract. So I say 2x times x squared is 2x to the 4th. 2x squared times 0x is 0x cubed. And then 2x squared plus 9 times 9x is plus 18x squared. So now I'm going to change all my signs in here. And I'm left with 15 minus 18 gives me -3x squared. X cubed minus 0 is just going to leave me with x cubed. And then my x to the 4th cancels out. And I bring down my plus 9x. Now, same thing, first term into first term. So x squared goes into x cubed 1x times. So plus x. Get this ready, your subtraction before you multiply. x times x squared is x cubed. X times 0x is 0x squared. Doesn't matter what sign you put. And then x times 9 is plus 9x. So now let's get our everything distributed. My x cubes cancels out. Negative 3x squared minus 0x squared is just negative 3x squared. 9x and negative 9x cancel out. Bring down your negative 27. Again, first term into first term. So x squared times what gives me negative 3x squared? That's going to be negative 3. So get your subtraction ready. Negative 3 times x squared is negative 3x squared. Negative 3 times 0x is 0, so we don't have to put anything. And then negative 3 times 9 is negative 27. Get your subtraction all done, and you're left with 0 remainder. So your last two zeros, because I have 2 of them now, there's 2 left over, is going to be at 2x squared plus x minus 3 equals 0. So now we just factor. A times c is negative 6. What are the factors? So my factors would be 3 and 2, right? So x plus 3, x minus 2. And since my a term is not 1, I have to divide both by 2. So I'll go up here to finish this up. So 3 does not divide pretty by 2. So we come up here. 3 doesn't divide by 2 pretty, so we're left with 2x plus 3 and x minus 1, because 2 divides by 2. So here I have x. When I move the 3 over, it becomes negative divided by 2. I have negative 3 over 2. And I have x equals 1. So I have 4 zeros. They are at negative 3 over 2, x equals 1. And then I have 2 more up here at negative 3i and positive 3i. All right, same thing goes for this one. I have x to the third power. That means I have 3 zeros. So I have x equals 3 plus 2i. I have x equals 3 minus 2i. And then I'll have my last x equals, which I'm going to find. So the first thing I'm going to do is take my x plus 3i and my x minus, so x equals 3 plus 2i, x equals 3 minus 2i. And I'm going to multiply these together. So I'm going to be left with x minus 3 minus 2i, x minus 3 plus 2i. Now we can use a little shortcut. What shortcut? I have x minus 3 quantity squared minus, the second term is 2i. So I have 2i squared. Well, when I work this out, this 2 goes to both of these. This gives me negative 4i squared. Cross that out, becomes plus 4. And then when I FOIL this out, I get x squared minus 6x plus 9. So when I simplify this, I get x squared minus 6x plus 13. And then I take that and I divide it into our original polynomial. So I have x squared minus 6x plus 13, and I'm going to divide that into x cubed minus 11x squared plus 43x minus 65. Now we do our long division, and again, this should work out nice and pretty. So x squared into x cubed goes x amount of times. So get your subtraction ready before you do your multiplication. X times x squared is x cubed. X times negative 6x is negative 6x squared. X times 13 is plus 13x. Distribute all your negatives throughout. So 43 minus 13 gives me 30x positive. Negative 11x squared plus 6x gives me negative 5x squared, and I bring down my minus 65. So now we go first term into first term. X squared times what gives me negative 5x squared? It'd be negative 5. So get your subtraction ready. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 6 is positive 30x. And negative 5 and 13 is negative 65. And when we go through and distribute all of our negatives, everything cancels out. So we're left with x minus 5. We set that equal to 0. And I know that my last 0, my last x value is at x equals 5. So this would be your answer right here. Okay, guys, moving on. We have 4 of these now where it just says solve. So that means figure out the x's. So the first thing you need to do is say, okay, look, it's x to the 5th. That means I should have 5 zeros. So I look and I say, do they have anything in common I can take out? Yes, they all have at least one x. So I'm going to take out an x, and I'm left with x to the fourth plus 5x squared minus 14 equals 0. So now I say, okay, this is a trinomial. Can I factor it? Well, yes, you can, because, guys, what times what gives you x to the fourth? That'd be x squared. And then what times what gives you a negative 14 when you multiply, but a positive 5 when you add? That'd be a positive 7, negative 2. So now set each piece equal to 0. X squared plus 7 equals 0, and x squared minus 2 equals 0. X equals 0, that's one answer. Subtract 7 from both sides, I get x squared equals negative 7. Take the square root of both sides, I get x equals plus or minus. I have a negative underneath the radical, so it's I, and then root 7 stays underneath. And then here I'm going to add 2 to both sides. So I get x squared equals 2. Take the square root of both sides, I get x equals plus or minus root 2. So there's our 5 answers. 1, 2, 3, 4, 5. Over here I look and I say, okay, I have 4 terms. Well, first, do they have anything in common? All 4 of them? No. Secondly, if I group, is that going to help me with anything? I could see it right off the bat, it's not. So that means we have to use our rational zero theorem, our P over Q. So I'm going to take all the factors of 24. So plus minus 1, 2, 3, 4, 6, 12, and 24. So we're going to start our synthetic division and just see which one works as a factor. So I'm going to start with 1. So my coefficients are 1, 5, negative 2, negative 24. So bring down the 1. 1 times 1 is 1. 5 and 1 is 6. 6 times 1 is 6. Negative 2 and 6 is 4. This isn't going to work. So try negative 1. Again, 1, 5, negative 2, negative 24. Bring down the 1. 1 times negative 1 is negative 1. 5 and negative 1 is 4. 4 times negative 1 is negative 4. Negative 2 and negative 4 is negative 6. Negative 6, this doesn't work. Okay, so let's try 2. Again, my coefficients are 1, 5, negative 2, negative 24. So I bring down my 1. 1 times 2 is 2. 5 plus 2 is 7. 7 times 2 is 14. 14 and negative 2 is 12. 12 times 2 is 24. Negative 24, positive 24, 0. So x equals 2 is one of my answers. So now my resulting polynomial, this would be x squared plus 7x plus 12 equals 0. What are the factors of 12 that multiply to give me a positive 12 but add to give me a positive 7? So it's x plus 3 and x plus 4. So I have a 0 at x equals negative 3, and I have a 0 at x equals negative 4. So my 3 zeros are x equals 2, x equals negative 3, and x equals negative 4. If you guys were to be asked if you had multiplicity, do you have the same answer more than one time? No, you don't. So you'd either say no multiplicity or there's a multiplicity of 1. Each answer you see just one time. All right, moving along, same thing here. Grouping's not going to work. There's no GCF, so I'm going to list the factors of 12, plus minus 1, 2, 3, 4, 6, and 12. Start with 1 on our synthetic division. So I have 1, negative 7, 16, and negative 12. Bring down the 1. 1 times 1 is 1. Negative 7 and 1 is negative 6. Negative 6 times 1 is negative 6. 16 and negative 6 is 10. This isn't going to work. Try negative 1. 1, negative 7, 16, negative 12. Bring down the 1. 1 times negative 1 is negative 1. Negative 7, negative 1 is negative 8. Negative 8, negative 1 is positive 8. 16 and 8, too big. Nope. All right, let's try 2. So I have 1, negative 7, 16, negative 12. Bring down the 1. 1 times 2 is 2. Negative 7 and 2 is negative 5. Negative 5 and 2 is negative 10. 16 minus 10 is going to give me 6. 6 times 2 is 12. Negative 12 and positive 12 is 0. So x equals 2 is one of my answers. So now I'm left with x squared minus 5x plus 6 equals 0. Well, what are the factors of 6 that multiply to give me a positive 6 but add to give me a negative 5? That'd be x minus 2 and x minus 3. So I have x equals 3 and x equals 2. So here are my three answers, and I do have multiplicity. There is multiplicity here because I have the same answer more than one time. So I come here and I have x to the fourth, right? I can't, there's no GCF. I look at this and I say, can I use the quadratic formula? I can't because it's x to the fourth. So let's think for a second. What times what gives me x to the fourth? Be x squared. What are the factors of 75? That could multiply to give me 75, but add to give me 20. Well, 25 and 3 won't work. 1 and 75. How about 15, positive 15 and positive 5? 15 times 5 is 75. 15 plus 5 is 20. So set each of these equal to 0. And solve. X squared plus 5 equals 0. So I'm going to subtract 15. I get x squared equals negative 15. Take the square root. And you get x equals plus or minus I root 15. It's imaginary because there's a negative underneath. Here I'm going to subtract 5 from both sides. So I get x squared equals negative 5. Take the square root and I get x equals plus or minus I root 5. So these both are imaginary solutions on each binomial, and there's two each. So there's 4 solutions and they all just happen to be imaginary. All right, second thing, or not second thing, but here, guys, it says find the polynomial with the given zeros. They gave you the zeros, x equals 3, x equals 7i, and we always have to make sure that we account for the complex conjugate. So x equals negative 7i. So first thing I'm going to do is write my binomials. So this would be x minus 3 when I move it over. This becomes x minus 7i, and this becomes x plus 7i. And this is set equal to 0. So I'm going to FOIL these two together, or I can use the trick, whatever you want to do. So x times x is x squared. Negative 7xi, positive 7xi will cancel out. Then I have minus 7 times 7 is 49, and I squared. I squared, I cross off, and I put a plus. So I'm left here with x minus 3 times x squared plus 49. We're going to FOIL again. X times x is x cubed. X times 49 is plus 49x. Negative 3 times x is negative 3x squared. And negative 3 times 49 is a negative 147. And then we're just going to rewrite this in standard form. So x cubed minus 3x squared plus 49x minus 147 equals 0. Make sure you have equals to 0 because you're writing the resulting polynomial. All right, we come here. We actually have 4 zeros in this case. We have x equals negative 2, x equals positive 5. Ooh, actually, I think that says 5 minus 4i. Yeah, that's true. Okay, so this is 5 minus 4i, and this is going to be x equals 5 plus 4i, complex conjugate. So when I rewrite my binomials, this comes over here, I have x plus 2. Bring this over, it's x minus 5 plus 4i. Bring this over, I have x minus 5 minus 4i. And this is all set equal to 0. So we're going to leave x plus 2 out here, and we'll bring it down in a second. But we're going to do the shortcut here. I have x minus 5 quantity squared. I have 4i and 4i. So that gives me 4i quantity squared, and I have a minus sign in the middle. So x minus 5 quantity squared would give us x squared minus 10x plus 25. If I distribute this here and here, I get negative 16i squared. Cross off the I squared, it becomes plus 16. And then I have my x plus 2 out here, equals 0. So I have x plus 2. X plus 2. Clean this up a little bit. I have x squared minus 10x plus 25 and 16. So it'd be 41. Why does that keep doing that? Equals 0. And then we multiply again. So x times x squared is x cubed. X times negative 10x is negative 10x squared. X times 41 is plus 41x. 2 times x squared is plus 2x squared. 2 times negative 10 is negative 20x. And 2 times 41 is plus 82 equals 0. So now clean it up. I have x cubed, negative 10x squared, and a positive 2x squared gives me minus 8x squared. 41 minus 20 gives me plus 21. X plus 82 equals 0. On the review itself, I worked this out as 4 different zeros, as x equals negative 2, x equals positive 5, x equals negative 4i, and x equals positive 4i. So on your test, I'll make sure that you guys can tell if this is 1, 0, or 2. You can look at it both ways. It's a good little reminder. All right, here again, we're going to write the polynomial. I have x equals negative 7, x equals 2 plus 3i, and I have x equals 2 minus 3i. Always account for the complex conjugate. So we have x plus 7, x minus 2 minus 3i, x minus 2 plus 3i, all set equal to 0. We're going to bring down x plus 7, and we're going to do our little trick. So I have x minus 2 quantity squared minus 3i quantity squared. So if I distribute this here and here, I get x squared minus 4x plus 4. And then this was going to be 9i squared. Cross off the I squared plus. So we have x plus 7 times x squared minus 4x plus 13 equals 0. And now we multiply. X times x squared is x cubed. X times negative 4 is negative 4x squared. X times 13 is 13x. 7 times x squared is plus 7x squared. 7 times negative 4 is negative 28x. And 7 times 13 is plus 91 equals 0. So clean it up. X cubed, negative 4x, and a positive 7x is plus 3x squared. 13 minus 28 gives me negative 15x, and then plus 91 equals 0. Okay, for the rest of these, 12 through the bottom, you guys should have this cheat sheet. You should have it somewhere around you when you're taking your test. If you're in class, you'll have it on your desk. I'll get it to Mr. Cabrera so he can get it printed out. But it should be on your desk, guys. So as you work this through, vertical asymptotes and domain, those go hand in hand. Vertical asymptote and domain goes hand in hand. So our vertical asymptote is where we would set our denominator equal to 0. So you have 5x plus 2 equals 0. Subtract 2 from both sides. 5x equals negative 2. And you get x equals negative 2/5. So you have a vertical asymptote at x equals negative 2/5. Your domain would be, you can use anything in the entire world except that number. So it would be negative infinity to negative 2/5 union negative 2/5 to positive infinity. You have to use interval notation for your domain. All right, we move over here to 13. Same thing, vertical asymptote. We're going to set the denominator equal to 0. So x plus 2 equals 0. Minus 2 on both sides. You have a vertical asymptote at x equals negative 2. That means my domain is I can use anything in the entire world except for negative 2. So negative infinity to negative 2. Union negative 2 to infinity. Denominator set equal to 0 for vertical asymptote. So x squared minus 25 equals 0. X plus 5, x minus 5 equals 0. So I have vertical asymptotes at x equals negative 5 and x equals positive 5. My domain is anything in the entire world except for those two numbers. So I'm going to write an interval notation left to right. Negative infinity to negative 5. Union. Negative 5 to 5. Union. 5 to infinity. All right, I come here and I say, ooh, I'm going to talk about slant asymptotes, and I'm going to talk about vertical asymptotes. So vertical asymptote, remember guys, we just did this. Vertical asymptote is denominator equal to 0. So I say, okay, minus 3 minus 3. I have a vertical asymptote at x equals negative 3. Slant asymptote is when we use long division and the remainder does not matter. So I'm going to say, okay, x plus 3 divided into x squared, what is it, plus 7x plus 10? All right, so first term into first term, x goes into x squared, x. Get your multiplication ready before you, your subtraction ready before you multiply. X times x is x squared. X times 3 is plus 3x. Distribute the negative, and this becomes 4x plus 10. Those cancel out. So x into 4x goes plus 4. Get your subtraction ready. So 4 times x is 4x. 4 times 3 is 12. Distribute the negative, and I'm left with a remainder of 2. But remember, guys, that does not matter. The only thing that matters is your y equals mx plus b. So you guys would tell me you have a slant asymptote at y equals x plus 4. You have to write it in y equals mx plus b form. Y equals x plus 4 would be your slant asymptote. Factored. And, all right, you'll definitely have one of these on your test where you have to give absolutely everything. So here you should have your cheat sheet handy so you can see. And this is how I want everything written so you guys can see it nice and neatly organized. But the first thing we're going to talk about is domain. Remember, domain and vertical asymptotes go hand in hand. Set the denominator equal to 0. So vertical asymptote and domain, they go hand in hand. I'm going to say x squared minus 3x minus 4 equals 0. What are the factors of negative 4 that multiply to give me a negative 4 and add to give me a negative 3? That'd be minus 4 and plus 1. So I have a vertical asymptote at x equals 4, and I have a vertical asymptote at x equals negative 1. So I would say x equals negative 1 and x equals 4. Well, I can also write my domain from that because it's every number in the world except for those two. So it would be negative infinity to negative 1, union negative 1 to 4, union 4 to infinity. Next thing we're going to talk about is our horizontal asymptote. If you look at your cheat sheet, horizontal asymptote is where we compare the numerator degree to the denominator degrees. So I always write n and d. So the numerator degree is 1, the denominator degree is 2. 1 and 2. Here you guys are telling me that 1 is less than 2, so we look at our cheat sheet, and what happens when the numerator degree is less than the denominator degree. And our cheat sheet says that means you have a horizontal asymptote at y equals 0. So you're going to write up here y equals 0. As far as slant asymptote goes, all right, slant asymptote is when you have to use long division. Guys, you're only going to have a slant asymptote if the numerator degree is higher than the denominator. If I were to divide this, like if I did x squared minus 3x minus 4 into x, that doesn't work. So if your denominator degree, or if your numerator degree is bigger than your denominator, then you'll have a slant asymptote. In this case, you don't, so you just put none. Don't just leave it blank. For our x and y intercepts, you plug in, what do we do? For x-intercept, you set the numerator equal to 0. So x-intercept, numerator equal to 0. So when I set the numerator equal to 0, I get x equals 0. You write that as an ordered pair, and it's 0, 0. For y-intercept, we plug in 0 for all of our x's. So I'm going to say, okay, my y-intercept is going to be 0 over 0 squared minus 3 times 0 minus 4. So I get 0 over negative 4, which is 0. So my y-intercept is at 0, 0. For our wholes, we factor the numerator and the denominator and see if anything cancels out. So I'm going to say, okay, for my whole, it's x over, and we factored it to x minus 4, x plus 1, right? Well, nothing cancels out. Nothing's exactly the same on top and bottom. So for wholes, you would say there is none. All right, moving along, we're going to do the exact same thing here. Remember, domain and vertical asymptotes go hand in hand. So I'm going to set the denominator equal to 0. X squared minus 25 equals 0. X plus 5, x minus 5 equals 0. So I have vertical asymptotes at x equals negative 5 and x equals positive 5. So x equals negative 5 and x equals positive 5. That means I can write my domain based upon that. It's negative infinity to negative 5, union negative 5 to positive 5, union 5 to infinity. That looks weird. Horizontal asymptote, remember we compare the numerator degree to the denominator degree. So I have n and d. Degree of the numerator is 2, degree of the denominator is 2. So when you have the same degree on top and bottom, your horizontal asymptote is at the leading coefficient of the numerator over the denominator. So 2 over 1. So you have a horizontal asymptote at y equals 2. Slant asymptote. Remember, the numerator degree has to be higher than the denominator. It's the same, so your answer here would be none. If I'm going to find intercepts, my x-intercept, x-intercept, we set the numerator equal to 0. So divide both sides by 2. X squared equals 0. Take the square root. You get x equals 0. We write that as an ordered pair as 0, 0. To find our y-intercept, you're going to plug in 0 for all the x's. So y-intercept, I'm going to say, okay, it's 2 times 0 squared over 0 squared minus 25. So that gives me 0 over negative 25, which gives me 0, 0. Good. And for wholes, we factor. So if I factor the top, I have 2x squared over, the bottom would be x plus 5, x minus 5. Is anything exactly the same that I can cancel out? No. So your wholes would be none. Okay, guys, same drill. Domain, vertical asymptotes go hand in hand. So we'll say vertical asymptote domain. That's setting the denominator equal to 0. So x squared minus 9 equals 0. Gives me x plus 3, x minus 3. So I have vertical asymptotes at x equals negative 3 and at x equals positive 3. So when I write my vertical asymptotes, it's at x equals negative 3 and x equals positive 3. That means my domain is anything in the entire world except for those two numbers. So left to right, we go negative infinity to negative 3, union, negative 3 to 3, union, 3 to infinity. Now we talk about horizontal asymptote. Remember, that's where we compare the numerator degree to the denominator degree. So I look at the degrees. Both the degrees are 2. They're the same, guys, remember. So horizontal asymptote, numerator degree, denominator degree, both 2. So that means it's leading coefficient over the leading coefficient. So y equals 1. So my horizontal asymptote is at y equals 1. Slant asymptote, I've told you guys before, you only have a slant asymptote when the numerator degree is above the denominator degree. Since they're the same, your slant asymptote would be none. Our x-intercepts are when we set the numerator equal to 0. So x-intercept, my numerator is x squared minus x. Let's make that a minus 12. Set that equal to 0. Let's change that real quick. Change that to a minus 12. It'll work out better if we do it this way. So when I factor this, I get x minus 4, x plus 3 equals 0. So I have an intercept at x equals 4 and one at x equals negative 3. So we're going to write that as an ordered pair. So my x-intercept is going to be negative 3, 0 and 4, 0. Our y-intercept is where we plug in 0 for all of our x's. So we'll do that in green. All right, we'll do our y-intercept right here. So I'm going to have 0 squared minus 0, 0 squared minus 0 minus 12 over 0 squared minus 9. So this all cancels out. I have negative 12 over negative 9. When we simplify, divide top and bottom by 3, and a negative divided by a negative is a positive, so I get positive 4/3. So my y-intercept would be at 0, 4 over 3. And then my wholes occur when we factor the numerator and the denominator, and we have common factors that cancel out. So our numerator factored, we'll do wholes up here. So wholes, our numerator Okay, our numerator factored was x plus 4, no, x minus 4. X minus 4, x plus 3, over x minus 3, x plus 3. So you guys notice the common factor is x plus 3, so you would say x plus 3 equals 0. You have a whole at x equals negative 3. So you would write whole at x equals negative 3. All right, last one. Again, domain vertical asymptotes go hand in hand. For our domain and our vertical asymptote, we're going to set our denominator equal to 0. So vertical asymptote domain, I have x plus 2 equals 0. That means I have a vertical asymptote at x equals negative 2. So if my asymptote is at x equals negative 2, then my domain, when I read left to right, negative infinity to positive infinity, is every number in the world except for negative 2. So it's negative infinity to negative 2, union, negative 2 to infinity. Then I talk about my horizontal asymptote. Guys, remember, that's where we compare the degrees. So the degree of the numerator and the denominator. Numerator degree is 3. Sorry, no, it's not. It's 2. Right here, 2. The denominator degree is 1, so 2 is greater than 1. When your numerator degree is bigger than your denominator degree, your horizontal asymptote is none. There isn't one. Slant asymptote is long division. Guys, remember, I told you, if the numerator degree was bigger than the denominator degree, you have a slant asymptote. So this is the case here, x plus 2. And then on the inside, I have 3x squared plus 5x minus 2. Remember that the remainder does not matter. So I go x into 3x squared is 3x. Get your subtraction ready before you multiply. 3x times x is 3x squared. 3x times positive 2 is plus 6x. Distribute that negative. So I'm left with negative x minus 2. X into negative x goes negative 1 times. Get this all set up. Negative 1 times x is negative x. Negative 1 times 2 is negative 2. Well, when I distribute my negative, everything cancels out. So my slant asymptote is at y equals 3x minus 1. It has to be written in slope-intercept form. X-intercepts, guys, x-intercepts is when we set the numerator equal to 0. So x-intercept, it's my numerator equal to 0. So that's 3x squared plus 5x minus 2 equals 0. Well, a is not 1, so I need factors of negative 6 that multiply to give me a negative 6, but add to give me a positive 5. That's going to be x plus 6, x minus 1. My a term is not 1, so I'm going to divide everything by my a term. This leaves me with x plus 2. This doesn't divide pretty, so I have 3x minus 1 equals 0. Set them both equal to 0. I have an intercept at x equals negative 2. And I have an intercept at 1 goes over, becomes positive, divide by 3, so 1/3. We write our intercepts as ordered pairs. So it's going to be negative 2, comma 0. And 1/3, comma 0. Our y-intercept is when we plug in 0 for all of our x's. So I'm going to plug in for y-intercept. It's 0 for x, so I have 3 times 0 squared plus 5 times 0 minus 2 over 0 plus 2. Well, this cancels out, so we have negative 2 over 2, so my y-intercept is at negative 1. My y-intercept is going to be at 0, negative 1. And lastly, ladies and gents, we talk about wholes, right? Wholes is when we factor everything. Factor numerator, factor the denominator, and see what they have in common. So we've already factored the numerator with our x-intercepts. It was x plus 2 and 3x minus 1. My denominator is x plus 2. We're doing wholes here. So as you guys see, x plus 2 is a common term. So we cross it out and we set it equal to 0. So that means I have a whole at x equals -2. So I would say whole at x equals -2. And that, ladies and gents, is your whole review worked out. So now you have all of the answers posted worked out. You have this video worked out. Come to class tomorrow and ask me questions.